All right, let's see if this tuner works. I don't know if anything good is on now or not, but let's see if we can tune in. How about that? Okay, all kidding aside, the tuner is working perfectly. I could do a channel sweep on it and let you see, dial sweep. But honestly, this tuner is really good. Okay, now for the fun part. We're going to test the crap out of this amplifier because of how much work we've done to it. I mean, replacing the output transistors, recapping it, completely gutting and replacing the power supply, you name it, rebuilding the flat amplifier and the tone amplifier. So we want to make sure this thing works. So I'm just going to kind of start at the beginning, and we're going to work our way all the way up to the fun stuff. Now the amplifier is turned on and it is warmed up, and that's really important. You want the amp to be up to kind of a operating temperature before you do these tests. And one of my biggest concerns with large amplifiers like this one, I mean, this is 270 watt per channel rated amplifier. You have to make sure the bias and offset and everything are set properly on these, because what can happen is they can sound great at high volumes, because that's really, they're designed to run at high power and high volume levels. But can you get it down to a tiny little whisper and still get really clean, distortion-free sound? And that's really important. So right now, I have the muting switch on, as you can see. I have both of the distortion meters on, and as you can see, I have them set to 1 volt range, the 1 volt scale. So it's going to look at very tiny signals. And what we want to look at is, if there's going to be crossover distortion, it's going to have its greatest influence at very low listening levels. So that's really what I'm looking at right now. This is a hard test to do because any kind of noise that's introduced through the cables or through the test equipment or anything like that is going to show up in the distortion. So it's never going to have as low of a distortion as you might get once you get up past that kind of noise floor thing. And that's important because that's real world listening. You're going to listen to this at low volumes sometimes. So we want to see what it does. So I have my scope set right now at 500 millivolts per division. I'm going to go to 200 millivolts per division, which is very low. You can see there's a little tiny bit of offset there. So we're definitely going to have to touch the DC offset adjustment. So I'm going to do that right now. Let me get a tweaker here. And the yellow channel, I believe, is the left channel. So that would be this one. And that's going to be this. And I'm going to see if I can get that to zero out. There we go. Nice. Nice. And the right channel is perfect. Now that noise that you're seeing on there right now, and I'll zoom in a little bit, that is noise from the scope itself. So that's really not noise coming off the amplifier. Again, we're using a ×10 probe, and we're using a very low scale. So you're going to see things like that. This is all important when you test this. All right, so let's turn the volume up just a little bit to get a little bit of signal there. And you can see you're only looking at about 50 millivolts of signal. And the scope's having a really hard time triggering on it. And if you look at the distortion meter, it's still staying around 0.05, 0.06. And that's about it. We might be able to even read Yeah, there it's a little more solid there. And you can see it's about 0.06, let's say. That's pretty good for such a tiny little signal with all the noise. Now, this can also do THD plus N, or total harmonic distortion plus noise, but I have to change the settings on there and everything. I'm not really worried about that right now. You typically do that type of test with when you're looking at tuners and receivers and things. But anyway, that looks really good. Going to the other channel, should be about the same. You can see it's bouncing around. Again, it's very sensitive. And if I bring the voltage level up just a little bit, it starts to settle down very quickly. Now I'm only at about 80 millivolts of signal to the speaker. That one settled right down. See that? So that's good. And you can see right there. All right. So we passed that test. Okay, the next test we're going to do is 10. We're going to do 10 watts into an 8 ohm load. So that's going to be just around between 8.9 and 9 volts RMS. So what I want to do is I'm going to focus you in here, and the first thing and this isn't super critical. It doesn't have to be exactly 10 watts. That's just a good listening level. So I'll bring this up till I see about 10 watts. And this is going to kind of work out the amplifier a little bit. All right, 8.85. That's pretty good. That's about, I can go a little bit more, maybe one more click. That's too far. And I have the muting on, so that's just a little bit under 10 watts. And let's go look at the distortion there. Look at that. And look at the other channel. Almost identical. I think I have the filter set a little bit. I don't have the filter on this one, and I have the filter set on the other one. So that's why it's bouncing around a little bit. But they're identical for all intents and purposes. And there with the filter on, it's rock solid. So it's very close. This one's 0.01 and the other side is 0.009. So very, very close. So that's good. Okay, while this thing is running, I'm feeling the heat sinks. I just want to make sure they're not getting abnormally warm, and they're not. They're just, now they're above room temperature. And I'm going to switch from a sine wave to a square wave. And you can see we have a very nice looking square wave. Okay, let's look at this next test. And what I'm looking at is the slew rate. Why is the slew rate important? Well, it's going to kind of show us the maximum frequency that the amplifier can reproduce get at certain power levels. So right now I drove the amp till we started to see a little bit of ringing. So we're, you know, I think up here we were somewhere around between 120 150 watts. I didn't really measure it, but enough to get this slope here. And I took 2 points right on the linear part of that slope, and that's going to kind of show us where we are with that. And right now, the nice thing about this MDO 2204 is that you can do measurements like this, where you can use the cursors and it'll automatically calculate the slew rate. And you can see dV over dt, and it's they read it out in millivolts per second, but that's also the same as volts per microsecond. That's just kind of how it works out. So you can use that same number. So your slew rate is 16.2 volts per microsecond. That's a really important number. Using that number now, we can calculate the maximum amount of power we can drive into our 8 ohm load and still get whatever frequency we're looking at. So now let's go down and look at some of the math here. So the first thing we have to do is calculate the maximum peak voltage that we need that we can produce, let's say, and still maintain whatever frequency we're looking at. So the first thing I want to check is 50 kilohertz, because 50 kilohertz is way above, more than twice the 20 kilohertz hearing range. So that's going to allow for things like harmonics and things, because a lot of people believe that the upper harmonics or the upper frequencies can produce lower harmonics and so forth. I don't buy into all that stuff, but let's just play the game here. So at 50 kilohertz, to measure the maximum peak voltage for a given slew rate, it's going to be the slew rate in volts per microsecond divided by 2 pi f, which is the frequency, times 10 to the negative 6. And that 10 to the negative 6 cancels out the microseconds in volts per microsecond. So that's what that's for. So again, if we do the math here, it's going to be your 16.2 volts per microsecond that we measured on the scope, times 2 pi f, which is 314,000. And if we do that times 10 to the negative 6, it comes out to 0.314. So if we take 16.2 divided by 0.314, that's going to give us about approximately, and again, I'm using, 6.28 as 2 pi. So I'm just rounding off my numbers a little bit. You're going to get approximately 51.6 volts peak. That's peak voltage, not peak to peak, not RMS. Or I mean, not that is your peak maximum voltage. Now, if we want to measure watts, you have to know the RMS voltage, or the root mean squared, the average voltage of that signal. So we have to times that by 0.707, or you can divide it by 1.414, however you want to do it. And that's for sine wave. And that's going to give us 51.6 times 0.707 is going to give us about 36.5 volts RMS maximum. So that's the maximum voltage that this amplifier can output before it distorts because of slew rate. And if we do the math on that, 36.5 squared divided by our 8 ohm load, you can put out a maximum of 166.5 watts into an 8 ohm load at 50 kilohertz without getting any kind of slew rate distortion, which is pretty good. Now you might say to yourself, this is a 270 watt per channel amplifier. What's up here? Well, it's because we're testing it at 50 kilohertz, okay? And chances of you outputting 50 kilohertz at 270 watts is pretty low on this. Just the way sound works, the higher the frequencies, you don't need as much power to get the same sound pressure level. I'm not going to get into all that in this. But let's just look at it at 20 kilohertz, which is the normal hearing range. And the same math applies. So you take 16.2 and 2 pi times the 20 kilohertz times 10 to the negative 6 is going to equal 0.1256. And that's going to come out to almost 129 volts peak. And you take that, and that's going to be 91.2 volts RMS. And you do the math into 8 ohms on that, that's over 1,000 watts. So this, at the 20 kilohertz range, this amplifier is way outperforming what it needs to do. And this, you got to remember, I'm testing this at the speaker terminals, which means the negative feedback and everything has already done its thing. And we can output up to 1,000 watts before we would see any distortion. And the amp is not capable of 1,000 watts, so it way exceeds, the slew rate way exceeds what we need for this amplifier. And I think this is a really good thing to look at, and that's why I figured I'd take the time to explain it and how it works. So there you go. Okay, here's the part I don't like. Let's take a look at what this amplifier does where it clips. So I'm looking at 20 volts per division now, and I'm going to run this up to hard clipping I'm going to hit the run stop button, and I'm going to turn the volume back down because I don't really want to overdrive this that hard for that long. But let's get it up here to clipping. Okay. And the first thing I see is both channels on the negative going. When it starts to hard clip, you can see we're getting some kind of a ringing on there. And that's not, I don't like that for sure. But it looks like we're getting about 49 volts. It's 49.6, 49.3. So it's clipping pretty good at 49 volts. And so if we do the math there, that's about 300 watts. So the amp is clipping right above its rating. You know, so it's rated at 270 watts per channel, and I'm getting about 300 watts at clipping. Now, this kind of concerns me because I don't think we should be seeing that on there. And let's stretch this out so I can look at that a little more closely. And I'm going to move the position over a little bit so I can get that closer to the center so we can look at it. And then I'm going to do this test once again so I can get a better view of it right there. And there it is. So, yeah, both channels are doing it. You see the right channel and the left channel. They both have a little bit of ringing on there. So I may want to look into why it's doing that. And that could be, I'll just have to look at it. Again, it doesn't do it until the amplifier clips, and then it's only just a little tiny artifact right there, but still it shouldn't be doing that. But the amp definitely can output 300 watts per channel with this tiny little anomaly on here. At the 270, of course, you're not going to get anything near that. So I'm going to run this up to 270 watts, which is about 46.5 volts instead of 49. I just want to see if it rings when it's up there. I don't know if this thing will do it. There's 46, and no, there's no ringing there. See, it's only when it clips, just at clipping. So that could have something to do with the Zabel network is not adequate for this. We may have to change a capacitor in there or something. It could be one of these bootstrap capacitors or something, but I'm going to look into that maybe a little bit. So it would be nice if we could get rid of it, but both channels are doing it equally, so it's definitely just something in the design of the amp, and we'll have to look at that. It could be one of the transistors being a little bit different than the original that was in there. It's a little bit faster transistors that I have in there or something. And this is the stuff you have to test whenever you replace transistors and replace components. You got to make sure that it can work like the original. The good news is this amp is just barely even getting lukewarm driving it like this. And I've been messing with this now for a little bit at the bench, and this thing's not really even heating up that much. So that's good. These heat sinks work really well. And let's just see what our distortion is doing at 270 watts. I'm going to drive it all the way up to that 47 volts. There we go. And you can see it's 0.069 THD at full power. Wow. Other channels just slightly higher at 0.07. Now some of you guys are going to be like, oh, it's not matched. One of them's got 0.01 difference. Yeah, okay. Whatever. So this thing's working fantastic. I mean, I'm going to check a couple of things. We're going to look at the tone controls next, and we're going to look at the phono stage, which I think that's going to perform perfectly. We already tested it before, and I think this thing's going to be ready to wrap up. Okay, the next thing we want to do is look at a square wave once again. And you can see there's a little bit across the top there with the controls at flat. This is this is the loudness control, and you see that's what it's supposed to do. All right, and let's turn the tone controls on, and that is a big problem. You can see the right channel is, I have all the settings of the tone control at flat right now. Technically, when you go from no tone control to tone control on, when all the tone controls are flat, it shouldn't change anything. Nothing should move. And you can see this channel does not move a whole lot. You can see it doesn't really move. But the right channel does. Look at that. See how it contorts down there? That's not good. So what that's doing is that means the high frequency is messed up. You can see right there. And when I turn it off, it's not. So what that's telling me is that there's something wrong on our tone control board. Okay, I'm now at 20 kilohertz. And you can see the two channels are pretty much on top of one another. And when I engage the tone control, you can see what the right channel's doing. And when I turn the frequency up and down, it makes a big change on the left channel, but not very much on the right channel. See that? So there's something wrong with that tone control section. Let's go to low frequency and see if the bass controls are messed up. Okay, I'm now at 30 hertz. And if I turn the tone control on at 30 hertz, you can see it's perfect. It doesn't change it. See, I go from tone control on, tone control off. Tone control on, and I crank the bass up and down, both of them. And you can see they move together. So it's something in the treble control on the right channel. This is why you do these tests. Okay, I took the board out and I checked. First thing I checked was all the components, and the capacitors and transistors are the correct values and they're all good. So then I got to looking at the board, and these are the treble controls right here. This one and this one. Down here's the bass controls. There's one and the other one's over next to it. But if I look at this one, look at that right there. It's almost like it's not even connected. It's like cracked or something. So I'm going to touch that up a little bit. I'll back you out so you can see. I don't know if that's could have done it or not. This front one's connected okay, but the back one is not. So let's heat those up. Yeah, look at that. It just came right off. Did you see that? Let's see what this one's doing. I'll heat them all up while I'm in here. Take a look. That's a lot better. These other ones look perfect. It's just those ones were really bad. I don't know if that was it. That'd be really strange if that was the problem. But whatever it is, it looks better now. This one still has a little bit of a, let me get a little bit of flux on there maybe. See if that flows a little bit better now. Trying to stick my head behind the camera here. There, that's better. All right. I really can't see any other thing that could be causing that. It's definitely got to be on this board. It's just the treble control that's out on one channel. So let me check a couple more things, and if everything looks good, we're going to put it back together and try it again. Okay, I popped the board back in temporarily. Let's turn the power on. Okay, you can see that little bit of DC offset as it turned on. All right, so let's turn on the signal generator, turn up the volume. Okay, so that's good. We're flat right now. Now let's switch into tone control. Ha! And see, they stay the same now. Now let's see if the treble controls work. Let me see. What frequency am I at? Oh, no wonder I am at the wrong frequency. So the bass, yeah, there goes the bass. And of course my fingers are all, because I don't have any of this grounded right now. So that's when I touch the knobs. All right, so let's move up to, I don't know, let's say 10 kilohertz. There we go. And change that. It's a wee little bit off, huh? Let's turn this off. That might be the balance control a little bit being slightly off. Yeah, that's what I think it is. Okay, well, I'm not going to worry about that. Okay, so treble up, treble down. Yeah, they're both working now. How about that? They're overlapped, so, okay. And then, perfect, it's fixed. So I guess it was that cracked solder joint on there. That blows me away. I can't believe that's all that was. Okay, well, fixed that one, didn't we? Okay, just doing a burn-in test on this amp. It's going to run it for about 10 or 15 minutes at 50 watts continuous 1 kilohertz sine wave, and you can see the waveform looks beautiful. This scope is just showing the output of the record outputs. And here's our distortion for the right channel. And here's our distortion for the left channel. So it's working really well. So we're just about ready to wrap this one up. Okay, running the amp at 10 milliwatts, which is really important because that's where your crossover distortion is really going to show. You can see the distortion is still very, very low. And I'm just about at the bottom of where this meter can actually read. And then here's the other channel. So you can see they're both doing a really good job. So this amp is perfect. All right, there it is with the covers on, all done. And play some Stranger Danger. By the way, do you know what this song is kind of related to? What do you think it is? Yeah, that's where it came from. I don't know if you know who that is, but that's the SOS band, and the song is called Just Be Good to Me. And this Stranger Danger reminds me of that song a lot. I mean, you can kind of hear it, especially when the bass and everything kicks on. It's not the same, but it's got that vibe to it. A little bit different, but same vibe. Anyway, thought I'd have a little fun with that. But it's all done, as you can see. And the amp is clean all the way up to 270 watts per channel like it's rated. Somewhere just under 300 watts, still has that little tiny pip on the negative half cycle. When it bottoms out on the half cycle and goes up, you see that tiny little pip. I don't think you would hear it at 300 watts. But believe it or not, I really looked through the whole amp. I tried to see where the dominant pole was, where that was being generated, you know, because maybe there was some phase margin problem or something, you know, in one of the stages there. And, you know, at high power, you know, when the amplitude was up too high, it was starting to get some oscillation at high frequencies. But honestly, I could not find where that was being generated. And both channels have that tiny little pip. It's identical on both channels. So it's definitely something in the design of the amp, and it could be one of the transistors that I replaced. Although every transistor I used in there was very, very similar in spec to all the others. The only one that had a little bit of difference was, well, I'll kind of show you here. If you look here, these two drivers here that drive the outputs, it's a 2SA968 and a 2SC2238, and I do have brand new ones of those, but they're so rare and they're so hard to get now. There are some on eBay and things, but you know, you trust that as you will. But I used MJE15032 and MJE15033, and I think that's the numbers. And the only difference was the transition frequency on these ones was 100 megahertz, and the other ones that I used were 30 megahertz, which is still a 30 megahertz component. I can't see how that would have that oscillation or have, you know, be too slow of a transistor where you would have, you know, a phase problem. So I really don't know what causes that little thing, but again, it doesn't hurt anything. It doesn't show up until you're in full hard clipping. So I'm going to just ignore it. The tuner is working perfectly, and everything is really, and the amp sounds fantastic. You see the test results. So I'm going to be really sad to see this one leave the bench, especially, you know, looking at just how nice it turned out. I mean, I didn't really do anything to this cabinet. I put a little bit of Howard's Restore on it. There's a couple tiny little chips on the side, at the very bottom edges where people were like lifting up, you know, on the veneer. But I'm not going to do anything about it. I think I'm just going to leave it as it is. It's in such good condition with the original. The powder coating turned out just absolutely perfect. If you look, I'm really happy with how that turned out. The faceplate cleaned up really well. Everything's perfect. So this one's going to go off the bench, and eventually I will get this other one onto the bench down here along with the Marantz 2500. You can see they're in the queue there. But I have a couple other videos I want to do, I've been wanting to do, and this has been holding me up. So I will take care of those first, then we'll get on those. That's it for this series. I think we're ready to go. And definitely, I think Dave is going to sell this one. I don't think he's going to keep this one in his collection. So it's going to go up for sale. And wow. I'm jealous of the person that's going to get this one. You know, it's going to be hard for me to see this go, but I have the other one. I'm not going to go as extreme on it if it's going to be mine. Maybe later on I'll make it this nice, but too many other irons in the fire, you know? And so we'll just get it working and kind of put it aside after we get it working. So you'll get to see like the other side of servicing one of these. So this was like extreme, you know, going through every little thing, tearing down the chassis, powder coating things, everything replaced. The next one you're going to see is replace what needs to be replaced, get it calibrated up, clean it. That's all, just clean it. I'm not going to paint anything, and see how it performs. And then later on it'll go on the shelf, and eventually I'll do this to it. But that's it for right now. And until next time, you know what I'm going to say. I wish you all peace, joy, happiness, and good health in your lives. We'll see you again real soon. And yeah, one of you commented, is this really my hair, or have I been electrocuted or shocked one too many times? And I answered, yes. All right. So here it is. And let me get a little picture for the thumbnail here. Me with the finished product, huh? Nice. And we'll see you again real soon, everybody. Take care. Bye-bye.